Chapter 10, Section 4 is looking at secants and tangents. Let's take a closer look at problem number 25. Here we're given two concentric circles with center E. AB is 40, CD is 24, CD is perpendicular to AE, and AB is tangent to C. If a chord is tangent to a circle, we know it's perpendicular. So the first thing I'm going to do is draw in EC. That'll give me some triangles to work with. And now, if a radius is perpendicular to a chord, we know that the radius bisects the chord. So if AB is 40, then AC must be 20. Actually, I'm going to use this diagram down here. And CD was given as 24. Again, we were told this is perpendicular, so that chord is bisected. And that means that CG is half of 24, or 12. Now I'm going to focus in on triangle ACG, this right triangle right here. If I know that CG is 12, AG is unknown, and the hypotenuse, in this case, would be 20 AC, I can use the reduced triangle principle, factor out the 4, and I can see that A is 3, 4, 5, so that's a 4, which means that AG has to be 4 times 4 because of the scalar. AG is 16. Now I can use the altitude on hypotenuse theorem to help me with the rest of the problem. And if you've forgotten that, please refer back to 9.3. where we had the altitude squared equals one part of the hypotenuse times the other part of the hypotenuse, or the leg squared equals the close part of the hypotenuse times the entire hypotenuse. So, looking at triangle ACE now, one leg squared is going to equal the close part times the whole thing. So AC is 20, AG is 16, and my AE is what I want to solve for. Zoom in on that a little bit. So 20 squared, and I'm doing this without a calculator, so I'm going to do it a little bit differently. 16 is 4 times 4, so that reduces to 5, that reduces to 5, so AE is 25. Zooming back out. If all of AE is 25, and this part is 16, AG is 16, that must make EG 9. Now, we could have confirmed that as well by using the other altitude on hypotenuse theorem, which would have said that CG squared, the altitude, is equal to EG times AG. And we knew CG was 12, EG is our unknown, and then AG was 16. So that ends up being 9 that way as well. So now I'm still looking at triangle ACE, where this is a right angle, that's a right angle. And I know that one leg squared, oops, that's a C, plus the other leg squared, I'm looking for the radius now of the circle, will equal the hypotenuse squared. And I know that's 20, and AE is 25. So again, I can use the reduced triangle principle, factor out 5, and see that B has to be 3, which means that CE must be 5 times 3, or 15. So now, if CE is 15, all radii of the same circle are congruent, so CE has to be congruent to FE. FE must be 15 as well. So if AE is 25 and FE is 15, then AF must be 10. FE is going to be AF, and that's what I'm looking for. AE is 25, FE is 15 because it's a radius, so AF must be 10.